You can choose to write this down, but I would recommend you don't. I'll post this up on Schoology. This is pretty straightforward. It's just one of those things that I have to cover, and I just go check. So on that list of things that you've got, time instant and time interval. We'll have a brief discussion about it, and then we'll move on. So, time instant, time interval. What's the difference, Graham? It's a very...
I know, but I don't know right now.
Okay.
I've seen this before.
Yeah?
I've never seen
It's
It's
Okay.
Monday.
Monday. Check. Well, I mean, just in everyday language, like what does the word interval mean? Like there's a time interval.
You go up by 5 seconds.
Like a 5-second interval, right? Like for example, when you're doing the beep test, would you say that the time interval gets shorter, right? How does that beep test thing work? Remind me. Like you have to, but does it go beep, 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 or does it?
No, it goes beep.
And you have to get to the other end before it beeps again.
Yeah.
And back, right? And then it gets shorter and shorter, right? So the time interval is getting smaller and smaller, like 5 seconds, 4 seconds, and so on, right? Okay. Okay, well, so in a scientific sense then, let's talk about an instant. An instant would be a single reading of the time. When someone says to you, what time is it?
9:03.
And if you're young, you pull out your phone and you look, and if you're old, you go like this, right? And I know I have to say at home, I have to say 9:05. I can't say 5 after. You know what?
I would get in trouble for a lot.
Do you?
Yeah, I would say 5 after.
Yeah. Who do you get in trouble with? What does she want you to say? Really?
Why?
No, it's that I know that I've gotten in trouble for saying it's what time is it? It's quarter after. Quarter after a while. Most people kind of know usually what hour we're in, kind of thing, right? Unless you've been out, it's partying all night kind of thing. Got your watch on upside down or something. Seen that happen before. It's 8 o'clock. No, it's not. Your watch on upside down. So an instant is a single reading of the time, a single point on a time series graph. If you've got a position time graph, it's literally a single point. Okay? It is not a really, really short interval. If you want to say an interval of 0 seconds, you're sort of on thin ice, gray area there, right? If you get into calculus, you'll learn more about making things smaller and smaller and smaller until they're basically, they assume that they're 0. And that idea of that interval, that short interval, comes into play there. So there's an example. You look at the clock, it's 2 o'clock. If you want to be more accurate, you might have to say it's 2 o'clock and 3 seconds or something, right? But it's literally a single reading of the time. Okay, whereas an interval is the difference between 2 time instants or readings, right? You actually take 2 instant readings and then do a subtraction. And that interval can be as small as you want. The time between 2 points on a graph has a duration of greater than 0 seconds. There's an example, 2 hours has passed. So if you've got a position time graph, it's 2 points on the graph. Again, this is all really basically meaningless, something I got to cover though. Building the foundation. I had a student once named Jordan Sawyer. He said to me, Mr. Bennett, is it kind of like the difference between a Polaroid picture and a movie? I said, you're absolutely right, right? Because a picture, even doesn't have to be a Polaroid. That was quite a few years ago. Polaroids, you remember those cameras? Have you seen those?
Disposable.
Yeah, no, well, I don't think it was disposable, but you press the button and the picture,
Oh, yeah.
spits out the front.
Look better.
Self-developing kind of thing, yeah. Old school film, though.
Honestly, that's better than we have now.
You think so?
You don't have to go all the way on Raleigh.
I guess. Yeah. People still print pictures?
I don't know.
I did the other day.
Did you? That reminds me, I got to print a calendar for my mother for Christmas, and better do it soon. I'll have to get on that. So anyways, yeah, difference between a picture and a movie, I guess. Okay, that's really all I got to cover. Forget it. Let's move on. Let's talk about now. You've got the sheet in front of you. This is the new and improved version you've got. So this is exciting because I've never actually spent time improving this particular little lesson. So I've sort of cleaned it up a bit, taken out sort of all the repetitive stuff and tried to make it a little bit more straightforward kind of thing. We will be using the clickers though.
Yes.
Are they up front there, Nick? Yes, they are. Would you get one there? Pull them out. Okay, so after this, you'll be able to find displacement from the DT graph, which I think in grade 10, all they really are concerned with is the shapes of them, which we will revisit as well. But we're going to get a little bit more detailed today, finding the actual displacement, along with the average velocity from a DT graph. Hopefully we get that far. That's the plan anyways. Okay, so, how did I didn't even put a picture of a train on your sheet, did I? I apologize. I wanted to put a picture of a train because Cole likes trains. There's even a spot there, isn't there?
Yeah. I think we should get a new seat.
Yeah. I apologize. In order to illustrate the concepts of position and displacement, we're going to use a locomotive, a train moving back and forth in front of a station as it shunts rail cars. So it's just moving the rail cars back and forth, kind of thing, straight line, left and right. The track is straight. Train station is our reference point for analyzing the motion of the locomotive, or not reference point, more like what was the word we used the other day? Origin or frame of reference. As we stand at the station, we notice that the locomotive is, I think I have to zoom down a bit here. As we stand at the station, we notice that the locomotive is 50 meters to our left. Sometime later it's still in front of us, still later it's 40 meters to our right, and later still it's located 10 meters to our left again. We could draw a diagram to represent the various locations of the locomotive as they're measured from our reference point, the train station. So the 0 is our train station. You guys have that, right?
Yeah.
And do you have the X1, X2? You do. Okay. So those are our 4 different positions. If we were to analyze the motion of the locomotive, we would need to know its change in position. Why did I just say that weird like that?
Because we should know that.
It's a key word, exactly. Change in position of an object, and we say that it has undergone displacement.
Change.
Or displacement equals change in position. That's the key concept there. Displacement is change in position. Okay, pretty straightforward up to there. So again, displacement is change in position. To determine any change in position, we would subtract where we started from where we ended up. So the displacement is delta x, and I've got a couple of symbols there. xf minus xi. And what do you think the f and the I stand for? Final and initial. Okay, so you always subtract final minus initial. Where you are, subtract from where you were, is your displacement. In this case here, x just stands for position, right? This symbol here, this triangle symbol here, delta. Delta, it's the Greek letter D. I think it's a capital D, I think. Is a much used symbol in physics which indicates a change in something and always subtracts the initial reading from the final. Final minus initial. The displacement of the locomotive for the first interval can now be calculated. So let's go back to our diagram. Where was it initially? Minus 50 actually, right? Where is it now? 0. So it's final minus initial. This is the final. This is the initial. So it's 0 minus 50. Is that what you've got on the next page? It is indeed. 0 minus 50 plus 50. We would say that it has undergone a displacement of plus 50 meters. 50 meters, exactly. These units are important. What does the plus indicate, Lane?
Two wrongs make a right.
To the
right.
Two wrongs make a right. 3 lefts make a right too. The plus simply means what?
It's going right.
Going to the right. That's all it means. How far?
50 meters.
50 meters. This tells us the locomotive moved 50 meters in a positive direction, which is to the right. Calculate the displacements for the other 2 time intervals. So you need to log in. I'm going to start this one right here. I would want you to do, and now I know it's kind of weird because it says question 1 is interval 2, but interval 2 is from 2 to 3. And question 2 is going to be from 3 to 4. Okay?
We have 4 and 5.
Oh, is that right?
Yeah, we have
Oh, okay.
One, two,
I apologize. Okay, so I need to make a few changes to that. So there it is there. So question 1 is from x2 to x3, and question 2 is from x3 to x4, and I apologize when you make some edits, things like that happen. So go ahead and make those changes while I do my attendance.
Oh, I can't answer.
Yeah, me either.
There we go. Come on.
Right? X3 is here.
How do you put a negative?
There's a negative sign in there.
I got it. Don't worry.
Okay.
Yeah, like a shift.
X4 is at minus 10, right? So it's going 50 to the left, right?
So whenever, when it says,
Yeah, go ahead, punch it in.
when it says x3 to x4, do you just flip them?
Yeah, well, it's from x3 to x4, so the math is x4 minus x3, right? Yeah, final minus initial.
Wow.
Yeah, you're right. There's nothing hard about this. So, yeah, minus 50 is the answer, right?
Okay.
A couple people didn't answer. Okay, so you've got 5 of them, I think, am I right?
Yeah.
What?
Okay, so flip the page over. It says state the displacement of each of the following changes in position. And then there's one at the bottom there where you have to do find a bunch and tell me which ones are the same. So question 1, 2, 3, 4, 5, 6 is this matching one here, which I will leave up on the screen because I don't think you have the matching thing, right? Okay, so go ahead and do those. I'm going to do attendance. I think it's 6 in a row to do. So those of you that just wandered in late, pay extra close attention because I'm going to explain it again. State the displacement of each of the following changes in position. In every case, delta x or delta d, however you want to put it, is final minus initial. So it's going from minus 8 to minus 2. So it's going to be minus 2 subtract minus 8. And if you need a calculator, go ahead and do that. Minus 2 plus 8 plus 6. I'm afraid I don't have any, no. Plus 6.
We have to do plus.
You should, it's like putting, good question, it's like putting the north on a vector
I
question.
don't think it lets you
So it is
put
important.
plus. I don't think it lets you put plus.
Yeah, you're right. Is that what you meant? Yeah. For now, you should,
Don't.
for now, you should write the plus, but a little while later, we just sort of start to ignore it. 'Cause, yeah. Okay, from 2 to minus 8 is going to be, Billy, let him be. He's got to learn this. He's walked in late here. Minus 8 subtract 2 or minus 10. Right? It's not hard. Not hard at all. Minus 8 subtract 2. 0 to 8 is going to be, you don't even need to write it down. It's plus 8, right? 8 minus 0. Need a calculator? Minus 8 to 20. 20 subtract minus 8. Plus 28, right? All pretty easy stuff. Last one, minus 8 to minus 8. Minus 16, I think, right? Okay, good. What about this one here? Which ones are the same? Everyone that answered got it right. So it is B, it's A and C, right? This one is going to be plus 3. What's this one? Minus 9,
Plus 3.
plus 3,
Negative 3.
minus 3, and A, E, F, and G don't matter because they're not even on the list.
Oh, we did them anyways.
Good for you. That would be plus 2, minus 3, plus 5, right?
Yeah.
Final minus initial. Okay, good. We can do that. Okay, now let's talk about it on a position time graph. I'm going to give you one more additional step.
I will never get you. Do something.
Don't expect like 47 questions like that on the exam, no.
I think that was the whole exam.
Yeah, imagine. That'd be called adding. Well, subtracting, I guess. Knowing the position of an object tells us something about the motion of that object, but it would be helpful to know the length of time it takes to undergo the displacement. Displacement and time can both be illustrated at the same time on a position time graph. The position time graph is capable of providing us with information about displacement, average velocity, and instantaneous velocity length that we'll be discussing in the future. These three calculations will be performed using a sample position time graph shown below. So, number one is displacement. Displacement is determined on a position time graph using the standard formula that you just used, except now I won't be giving you the numbers. You're going to have to read them off the graph. The final and initial positions are located on the vertical axis. That's here. And if you desire, a dotted line can be drawn from the graph to the position coordinate in order to easily identify the two positions. In other words, if you have to draw a little line across here, go ahead. In the example, I'm going to give you one example, and then you're going to do 5. So watch carefully.
An example.
In the example graph for time interval A, here's interval A right here. Interval A is from there to there. Okay, so this is 1, 2, 3, 4, 5 seconds to there. So it's from 0 to 2 seconds, right? The interval A is from 0 to 2 seconds. This one right here. See how they're labeled up top? A, B, C.
Did it just be 1 second?
Ours are labeled different.
Yours are labeled different?
This is all bottom.
Oh, yeah, they are. Yeah.
Are they really?
Our A's are like
The
4.
A, B, and C. Our A's are.
Oh, I bet you when I reformatted, they all jumped all over the place. And we'll have to use that.
It's like way over there.
Our F is at 16.
See, like over there.
He's in the middle.
Oh god.
He's in the middle of one.
So, what's the initial position here?
0.
It's the Y, not the X, right? The Y. So it's 0. And what's the final one? 6. So there it is right there. The displacement is 6 minus 0 or plus 6. I went up, I went to the right 6 meters. Or whatever it is.
Yeah, it's
Right? It's pretty easy, pardon me?
You're right. It was 6.
6 meters. Okay, so now you need to go ahead and do intervals B. There's B right there. C is the next segment. D is that small little flat one. E is the really steep one there. And F is that one right there. Okay, go ahead. 1, 2, 3, 4, 5. It shouldn't take you too long.
Okay, so after.
Go ahead and try. Let's go back, and even those of you that have wandered in late should go to this page so you know how to do this. Let's look at the example again. How did I get, it's interval A, so it's this one right here, right? What is the position at the start?
0.
0. You read it off the y-axis. Does this number down here matter?
Yeah.
No! This number does not matter at all. What number does this represent? It's the time. The y is the position. So it starts at 0 and it ended up at 6. So I went 6 minus 0.
This one's 6, 6.
Exactly, Lane.
So it's 1. 0.
6. I started at a position of 6. I ended at a position of 6.
So it's 1.
My displacement is final minus initial. They're both 6. Want to try again, Graham?
Go to kindergarten.
0. It didn't move. I heard Kieran say it's not moving.
Okay.
It's 0. It's flat.
He's talking. Let's see. What's the next?
Okay, so now do C. Again, read the positions off the graph and subtract.
We can't see what's here.
Go, yeah, go click the next one. Yeah, there you go.
There you go.
It's the next line segment.
So
That's just easy to see though.
Let's talk now about average velocity.
Where are we now?
Okay? We're on the next page now. So devices down, ears open. listening, learning how to do the next step. I'm going to show you.
Didn't say what I got.
You guys don't have that? Yeah, I know, because I combine it. I should really separate them. You don't have that.
No, not any of it.
Oh, Mr. Bennett.
I thought you said you improved this.
Well, I did. I just didn't finish it, I guess.
Just print that one page.
I wanna.
Let's just do it up here. Okay? Let's just, you know what you guys are going to do is you're going to go back to those intervals. Let me see here. Let's just put it right underneath there. You guys got a room on that last page there? Go back one page. Go back one to where the A, B, C, D, E, and F is. You got blank right there. Go back, Graham. We're going to get to that one. Go back. Go back to this page here that says A, B, C, D, E, F, right? Okay, watch carefully. I do apologize. This is what happens when you make edits. Things don't work out. They
Can we
get.
copy it down?
Yeah, you probably should. It's probably a good idea.
Now determine.
Now determine the average velocity for each interval. Okay? We're going to do the average velocity for each interval. So write this down on that page where it says A, B, C, D, E, and F. Oh, come. Average velocity. What did we just calculate? We calculated the displacement. No. The last 5 was displacement, right? The last 5 was displacement. So now determine the average velocity for each interval. Use the formula that you learned last year, which is displacement over time. Where did we get the displacements from? You just calculated all 5 of them, right? Distance, displacement is how far and what direction. So you just did displacement. Now you divide by the time interval. You divide by how long that time took. So for example, interval A, let's go back to interval A right here. Here's interval A. It was displacement of, we went from 0 to 6, but how long did it take us? 2 seconds. There's 1, there's 2, right? That there's 0, 0, 1, 2. Right? So we're dividing by 2. So my average velocity for interval A is 3 meters per second. I went 6 meters, 1, 2, 3, 4, 5, 6 in 2 seconds. Okay, so questions on your clicker.
Now time matters.
Now the time matters. So now questions 6 and 7 and 8 and 9 and 10 are all find the average velocities, take the displacements that you just calculated, and do what? Divide by the times. I'll say that again. In every interval length, you take the displacement and you divide by the time. Where do you get the time from? X across the bottom. Go ahead. Right here, Steve. Come on, man. You gotta stay with us. We're finding the average velocity.
You just did that question, didn't you?
I did A. B is from 2 to 6. No, I did A. I did interval A, this one. B is this one right here. Right? Then C. D, E, F. Take the 5 numbers that you just got and do what, Lance? Divide by the time. Take the 5 numbers that you just got and divide by the time. A time of that interval, yes. How long that interval of time is.
How long did it
Negative 4 satellites. 1, 2, 3, 4 seconds. Zero divided by 4. Zero. Go to the next one.
Yeah, it's imagine. The bottom one is time.
All we're doing.
Here, it's not. 1 second, 2 seconds, 2 seconds.
Okay, so what happens if you like
Negative
in high school?
10 divided by 4.
No, yeah. I'll take This is gonna let the gas like drop. Just pull out like close on it and let it run. Yeah, you get thrown over
Do you want a couple more examples? Sure.
These guys here. Okay, so this one, you can see is negative 10 divided by 4.
Yeah. C is negative 16.
Divided by 10, I assume.
So divided by 1, 2, 3, 4 seconds.
Like 4 seconds.
Because that's the displacement for interval
Oh.
It's how far you went in that interval divided by the time in that interval.
And then this
Oh,
one,
so it's just, so it's somewhere the last one.
Time interval, yeah.
I feel like it's 0 divided by 4.
Yep. Yep.
So C would be negative 16.
That actually is.
Yeah.
That's now for C. Go back to time.
Okay, so in every case. Right? Yep. Minus 4 seconds.
On
So then you would be.
Willie, are you going to enter some numbers in? Because I don't have anyone here for 6. 6 or 7 or 8. 11 is this one right here. This is 11, and then you'll get your score. If you're done everything, you can move on. There's a couple of practice ones there while you're waiting. There's 2 practice problems that you need to do for extra practice.
Can you go back?
Yes, Nick. No, they do not.
Okay.
Which one do you want, Lane?
That was 11. That's 11.
Then learn how to do it. I only got like 3 or 4 minutes left here. In all cases, V is equal to D over T. Just leave the clickers on the tables, you guys. I'll put them away. I need you to listen. Okay, don't pack up. Don't pack up. Listen. What's the displacement for interval B? How far does it go? We already calculated that the displacement was 0. It didn't go anywhere, and it took 1, 2, 3, 4 seconds, giving us an average velocity of 0 meters per second. It wasn't moving.
Why did it say I got it wrong then?
Correct answer 0. This is for number 6. I don't know, man. Let's look at 7. The important thing is that can we do it? Interval C is from 6 to 10 seconds, right? They're all displacement over time. How far did it go? It went from 6 all the way down to minus 10. It was a displacement of minus 16, and I'd really like you to show your work so that when you look back, you can see what you did. We're going to divide by 1, 2, 3, 4 seconds. Minus 4 meters per second was the average velocity. You got them all punched in the wrong order? Number 8, don't pack up, you guys. Just listen. Dylan, turn around, watch. You got 3 minutes. You're going to have a break. You still got me for 3 minutes. Interval D is this short little flat one. When they're flat, what's the average velocity going to be? 0. You don't even have to calculate it. When the slope is flat, the velocity is 0. E is from 12 to 13 seconds. The displacement was up 6, right? That's a T. It was up 6. How much time elapsed from there to there? Only 1 second. 6 meters per second. The last one. Average velocity for interval F. This one right here. What's the displacement? It goes from minus 4 to 0, so it's up 4 and over how much time? 1, 2, 3, 4. 1 meter per second. It's like doing slope, right? You guys did slope in math class? Rise over run? That's what we're doing. That's what we are doing. Last one. Don't back up. Don't. Weeds. Given the position time graph, determine this represents a real situation.
No.
The answer is
Go back in time.
and no. You cannot go back in time. It must go forward in time. Okay, I'm going to give you time. Hang on, you guys. Don't back up. The bell hasn't gone. Okay, you guys got a break. Sit down and just listen. Give me like 10 more seconds. Sit, Cole.
Sit.
I'll give you a dog biscuit. Okay? Peter, why have you got that earbud in? I'm not done talking. So why put it in if it's not playing? So you can have it at the ready. Well, I know what's more important to you, I guess, today. There's 2 problems there at the end. I strongly suggest you try some of those. Okay? Are the answers provided there?
Yeah.
I don't think they are, right? I'll give you a little bit of time tomorrow to work on those. You should at least try the very first one. Okay? We're going to have to move on as well. But you've got to be able to do these, you guys. Give it a go tonight. Try and figure it out. Now I'm done.
Okay.
Doesn't